Thank you for joining this lesson. Remember to subscribe to the channel and to also share the link with friends. Figure 9 shows one method of measuring the specific latent heat of fusion of ice. Two funnels, A and B, contained crushed ice at 0 degrees Celsius. We have funnel A and B containing crushed ice at 0 degrees Celsius. We can see A without an immersion heater, but B has an immersion heater whose power is 24 watts. Then we are told the mass of the melted ice from each funnel is measured after 11 minutes. The results are shown below. Mass of melted ice in A, 24 grams. Mass of melted ice in B, 63 grams. Part 1. What is the reason for setting up funnel A? So funnel A, without the immersion heater, is being used as a control experiment. A control experiment represents an ideal situation, a real situation, such that even without an immersion heater, ice could still melt. Therefore, now we can know the effort of the immersion heater after seeing that some ice could melt without immersion heater and more with immersion heater. We can see at least a difference. Determine the quantity of heat supplied by the heater. Quantity of heat supplied by heater, the heat energy will be given by power times time. So power of 24 and time, which is 11, we convert to minutes, or the minutes to seconds, that is, by multiplying by 60. 24 by 11 by 60. This is giving us 15,840 joules of energy. Then we are also supposed to calculate mass of ice melted by the heater. So mass of ice melted by heater is going to be, we have ice that has melted without an heater and that has melted with heater. So this means when we take the difference, we will get specifically the amount of ice which is getting melted by the heater. So 63 minus 24. 63 minus 24. This is giving us 39 grams, which is an equivalent of, when we make it as a units, 0.039 kilograms. That is what has been melted by the heater. Otherwise, melting could still have taken place at the rate of 24 grams in 11 minutes. The specific latent heat of fusion of ice. So here we are saying all the amount of heat which has been supplied by the heater is being used to melt up the ice. Therefore, we now say that heat supplied by heater, assuming no heat losses to the surrounding, heat supplied by heater equals to heat used by ice in absorption or in the melting, or to melt, or rather the heat of fusion of ice. Therefore, heat of fusion of ice is given by mass times latent heat of fusion, specific latent heat of fusion. But on the other side, it is power times time. This value has already been obtained at 15,840. So this is equal to mass of 0.039 multiplied by latent heat of fusion. So to remain with latent heat of fusion, we need to divide 15,840 with 0.039. So this is going to be 406,153.85 joules per kilogram. Joules per kilogram, because it is happening at a constant temperature. So there is no change in temperature. We cannot say joules per kilogram per Kelvin. It is strictly joules per kilogram. Thank you for following. Subscribe and share.